Welcome to day one of the CASE NCSEA SEI Joint Leadership Summer Series on Disaster Response and Lessons Learned. Our first webinar will be presented by NCSEA titled Answering the Call, Structural Engineers, NCSEA, and Disaster Response. Thank you for joining us. We are joined today by our moderator, Don Dusenberry. Don served for 45 years in the Engineering Mechanics and Infrastructure Division of Simpson, Gumpertz, and Hager, Inc., achieving the title of Senior Principal before beginning to diminish his role. He retired from SGH in 2021, but has remained active as a private consultant. Don has been active in professional organizations, including the Structural Engineering Institute of the American Society of Civil Engineers, for which he is a former president of its Board of Governors. Don is a former president of the board of the Applied Technology Council, and he has written and presented extensively on failure investigations and topics such as structural performance under extreme events, including blast, fire, and disproportionate collapse. At this time, I will turn the floor over to Don to begin. Introduce our presenter. Don?
Yes, thank you very much for the introduction, and welcome to everyone to the first of a series of 3 webinars. This is the second year, I believe, that this series has been put on by the 3 organizations. And last year it was on artificial intelligence, and this time it's going to be on an interesting topic of disaster response, as you well know. So today's speaker on the first subject is Klaus Perkins, who's a principal and department manager at Bennett & Pless, Inc. He serves as structural specialist with North Carolina Urban Search and Rescue Teams and is actively involved in disaster preparedness and response as a member of NCSEA's Structural Engineering Emergency Response Committee. Klaus was deployed to Puerto Rico for the earthquake in 2020 and Western North Carolina for Hurricane Helene in 2024. So now I'd like to turn it over to Klaus for his presentation.
Thank you, Don. Welcome, everybody, and thank you for joining me today. As indicated, this is the first of a 3-part joint summer series presented by NCSEA, CASE, and SEI covering disaster response. Sessions 2 and 3 will be presented on July 28th and August 25th and cover Good Samaritan protection and the impact of disasters on codes and standards, respectively. I encourage everyone to tune into these. Each session is paired with an article in Structure Magazine, so I hope you also get a chance to read those articles as well. So by the end of this webinar, all the attendees should be able to describe the structural engineer's role in post-disaster response, understand how rapid safety assessments differ from conventional design practice, explain how NCSEA and SEER support coordinated disaster response, and identify pathways for becoming involved in post-disaster assessment work. So why does this work matter? Structural engineers provide critical life safety decisions after disasters. The profession's role after an event is becoming more important as disasters increase in frequency and severity. Engineers provide rapid safety evaluations crucial to protecting lives and property during disasters. By quickly responding and assessing structures around the event, we can help people get on with their lives, get out of shelters, back into their businesses, especially when you consider that we can do more than just evaluate residential structures. We can evaluate bridges and roads, allowing for the passage of emergency response vehicles, and water and wastewater treatment facilities, improving overall sanitation. Depending on where you are in the country, you could experience one or more of these disaster events. windstorms in the form of tornadoes and or hurricanes, and oftentimes those who are have experienced hurricanes know that sometimes tornadoes happen with the hurricane. Flooding, which, as we have seen here in North Carolina, can occur in mountainous regions and are often the biggest threat during a hurricane. Earthquakes. We all know that the seismic hotspots across the country, but earthquakes can and do occur outside of these zones. Explosions that occur in both residential and commercial structures, urban fires, ice storms, and of course, terrorism or civil unrest incidents. The focus of the Structural Engineering Emergency Response, or SEER committee, is to prevent the unsafe reoccupancy of buildings following disasters through the training and certification of damage assessment professionals. The initiative emphasizes volunteer training, roster management, coordinated response efforts, and advocacy for certified professionals. SEER supports this effort with a comprehensive roster system that allows local, state, and federal agencies to access qualified volunteers for post-disaster assessments. In the bottom right, you'll see a QR code that'll take you to the SEER page, as well as the description of the link down at the bottom. I encourage everybody to click that link and explore more about SEER and what they do. Following the 9/11 attacks, the Structural Engineers Association of New York mobilized volunteer engineers to support rescue efforts and rapidly evaluate damaged structures at ground zero, with NCSEA and engineers nationwide joining the effort. This led to the formation of the SEER Committee in November 2001 to enable a coordinated, efficient response to future disasters. So an engineer's traditional engineering role is what we call left of boom, the phase 1 hazard event you see on the left side of the screen. That is pre-disaster. We design infrastructure that is cost effective, yet also robust enough to endure the rare but foreseeable overloads that natural disasters might impose. Our priority is protecting people, often by designing structures to absorb substantial damage and fail slowly enough to allow people to escape. But today, engineers are increasingly called to serve right of boom, or post-disaster. The graphic shows the typical sequence of recovery tasks after disaster strikes. Highlighted in the red box is where the volunteers in the SEER program fall. These are the second responders. I'd be remiss if I didn't mention those who deploy in phase 2. Our involvement as engineers is not limited to second responders. A few of us are also involved as first responders through state and federal search and rescue programs. Like medical or hazmat specialists, USAR teams often include structural engineers, or they're called structure specialists, in their deployments. In these cases, the goal of the structure specialist is to support rescue operations in damaged or collapsed structures by evaluating hazards, predicting collapse behavior, and recommending protective measures. Our job is to make sure the rescuers do not become victims themselves. So I've mentioned the word second responder. What is a second responder? A second responder is an individual with knowledge of building systems or some other specialty and trained in evaluating buildings after disaster. The purpose of the second responder is to support the local authorities by conducting rapid assessments of damaged structures with the goal of getting people out of shelters and back into their homes. I mentioned other specialties. In a previous slide, we talked about bridges and waste and water treatment facilities. Primarily, this program emphasizes, residential and commercial buildings, but depending on your specialty, you may be called to help with bridges and the more complex facilities like water and wastewater treatment facilities. There are several recognized classes of second responders. There is the ICC Disaster Response Inspector. This is put on by the When Disaster Strikes Institute of the International Code Council. There is the Safety Assessment Assessor, hosted by California Office of Emergency Services, or Cal-OES. There's also the FEMA Structure Condition Evaluator, which accepts the training of Cal-OES, SAP, and the ICC when disaster strikes. There is also a growing number of states developing their own programs that are tailored around their specific disasters that occur. The previous list I gave, as you know, some states do not experience many or any of those, and some are very specific. And they want to make sure that those programs that their second responders are trained to fit the disaster that is applicable to their state. This matrix identifies some of the qualifications needed for each classification. Our focus today is on the red box. The primary qualification is professional licensure, which includes professional and structural engineers, architects, geotechnical engineers or geologists, certified building officials, and fire inspectors. I do get a lot of questions from EIs about their ability to participate in this program. The answer is yes. As an EI, you can participate in a support role during assessments. These include completing forms, taking pictures, provided there's another in your group with the necessary professional licensure or certification conducting the actual assessments. Some additional requirements include first aid and CPR training, an understanding of the National Incident Command System, and successful completion of a course such as the ICC Disaster Response Inspector class or the Cal-OES SAP course, which I will note is taught twice a year through NCSEA and SEER. So stay on the lookout for that. The Applied Technology Council, or ATC, provides field manuals used to help volunteer engineers make on-the-spot evaluations about the use and occupancy of damaged buildings. ATC 20 covers post-earthquake guidelines, and ATC 45 covers evaluations for buildings after windstorms and floods. These manuals are based upon rapid visual assessment focused on life safety and occupancy and form the basis of the responder classes listed earlier. These assessments are not intended to provide a comprehensive forensic diagnostic or a detailed repair design. These manuals help ensure that evaluations are consistent and disciplined. The intent of these evaluations is to quickly identify and post buildings as to whether they are fully usable, partially usable, or unsafe. The criteria for these three main categories are the green, inspected, where there is no apparent hazard found. Repairs still may be required, but the lateral and gravity systems have not been significantly damaged, and generally occupancy is allowed and are fully usable. The yellow, restricted use, is for buildings that have been damaged but may or may not be habitable. There may be some falling hazards. There may be damage to the lateral or gravity system, but there is still some capacity to resist load. Note that this is where engineering judgment really comes into play. How much capacity is enough capacity when you're looking at the usability of a structure? In these yellow placarded buildings, restricted occupancy is permitted. The level of the restriction can vary depending on the damage. from avoiding a certain room or an area to being allowed to gather your belongings before evacuating the building. That's a pretty wide variety of situations. And then finally, the red unsafe placard. This is where there is an extreme hazard and the building may collapse. The lateral and or gravity system has experienced a significant decrease in capacity, and the building is deemed to be unsafe and requires permission from the AHJ to enter. Note that this does not mean it cannot be repaired or must be demolished. Some of the few pictures upcoming are from my deployment in Puerto Rico, kind of give you an example of what you may experience in the field. This is a red placarded building in Puerto Rico. Note the soft story collapse at the first level and how the second level is significantly below the top of the stair. Another red placarded building in a residential structure in Puerto Rico, obviously some significant damage. You note that the red placard is by the front door. I certainly question the location of this placard, why someone would put themselves at risk to put this placard there. And remember, in an earthquake scenario, it's not a matter of if there will be an aftershock, it's a matter of when there will be an aftershock. And you do not want to be standing on the porch when that aftershock occurs, regardless of the magnitude. This is a picture of some debris on a bridge from the flooding in Western North Carolina during Hurricane Helene. As I mentioned before, evaluating bridges could be also part of your mission, depending on your specialty. Another earthquake damaged home in Puerto Rico. Obviously, there's significant damage to the columns, but this is where your engineering judgment comes into play in your evaluation. Is that damage enough to get a red placard? What does the rest of the building look like? Is there some reserve capacity? Part of your assessment is to determine the extent of the damage. Can the owners be allowed inside for a limited time to get the belongings, or is no entry allowed? Another earthquake damaged home in Puerto Rico. Here's a question about means of egress. Clearly, the porch structure is in bad shape. The rest of the building may not look too bad. Is there another point of entry that someone can use and access the rest of the house, or is this the only one? As you conduct these assessments, the data is collected by incident command, where they track the progress of the teams to ensure no two teams are sent to the same neighborhood and to verify that the work is done as quickly and efficiently as possible. This image is of the data collected showing the different colors of the buildings that have been inspected. The green, yellow, and red. So this is what Incident Command uses to track our progress during our assessments, identify which roads and buildings have yet to be evaluated, and to make sure the teams are coordinated in subsequent days. As you can imagine, disaster response is very different from traditional practice. In traditional practice, you have complete drawings and record documents. You have analysis models, time for internal review, a defined scope and deliverables. In post-disaster response, incomplete information, time pressure, field conditions, sometimes immediate life safety decisions, and judgment-driven evaluations. Limited information is a big challenge in the field. You often cannot see everything you need or want to see. Fortunately, there are systems in place to request a more detailed evaluation at a later time, but you still need to make a determination of the usability of the structure at that moment. In the second bullet, I mentioned no real opportunity to come back later, but I've asked for a second opinion after I've completed my review of a building. This is another reason why working in teams is so important, the first being the overall safety of the team. When conducting these assessments, you often are in direct contact with the homeowners, who are understandably emotional and may question or challenge what you are saying, especially if you're putting a red tag on their home. It's interesting when you're doing these, you can put a green placard on someone's home and they still won't go inside the building. And then in some situations, you put a red placard on their home and they won't leave their building. So it really depends on the individual and their connectivity to their home. And sometimes I've received a question of, what will I do now? Where will I go now? This is a picture of a multi-story school in Puerto Rico that collapsed. Fortunately, the earthquake occurred outside of school hours and no one was injured. Another picture of a two-story residence in Puerto Rico with a soft story collapse. Sometimes the damage that you come across is not related to the incident at all. But it's important to remind yourself that you are not there conducting origin and cause evaluations. You're not there to determine whether the damage was caused by the tornado or the earthquake or the windstorm. That's usually a question for the insurance companies. You're there to conduct safety assessments and determine whether the home is habitable or not. And coming across situations like these, how do you make that judgment based on what you're seeing here? I mentioned the cause of the damage. It does play into it. Flood versus seismic damage and the need for reserve capacity. In a flood condition, like the image shown here during Hurricane Helene, you're not worried about aftershock. So you're not worried about, does it have reserve capacity? How does that play into your evaluation, whether you do it red, yellow, or green? That's part of that engineering judgment and following the guidelines of ATC 20 or 45. So why should you get involved in this work? The impact is significant. Many of the people you're going to meet and who you come across during these deployments are maybe going through the worst day of their lives, and you can make a difference. After evaluating a building in Puerto Rico and placing a yellow placard on it, the elderly couple thanked me for taking time away from my family to help them in their need and gave me a hug. Of course, there's always the flip side to that, when those homeowners don't want you on their property at all, which is understandable. As I mentioned earlier, aftershocks will occur. How you placard a building can make the difference if the occupants survive or not in during that aftershock event. Finally, I think I'm generally a better engineer because of my involvement in this work. I have a better appreciation about how our profession can protect the public, and my understanding of building systems and load paths are challenged and strengthened each time I am deployed. So how do you get involved? So the Disaster Response Alliance is a result of the International Code Council, the ICC, and NCSEA joining forces to help communities get up and running as quickly as possible after a major disaster. So the two organizations have created this website, and it's a national database of skilled volunteers willing to commit their time and knowledge to provide this help. It is through this database that we identify those interested, verify their credentials, and contact them when the need occurs. I encourage everybody to please scan the QR code to access the site where you can create an account and volunteer. Once in the system, you can upload your credentials, identify yourself as someone who is willing to do this important work. There's also a video that covers how to update your DRRA profile. I really encourage everybody to watch this, as it has some important settings that need to be activated to get deployed. Once you're in the system and an event occurs, we within the SEER group use this database to identify those who are trained with the required certification, whether it's Cal OES, SAP, or when disaster strikes, or some other approved program, and reach out to you for possible deployment. On the Disaster Response Alliance website, you'll also find lots of useful information, including links to the ICC website providing safety and recovery information for earthquakes, floods, hurricanes, tornadoes, as well as links to the NCSEA SEER page, links to Red Cross providing emergency preparedness tips, ready.gov covering disasters previously listed, but also lightning, power outages, wildfire, and extreme heat. A compendium of the Good Samaritan laws by state developed by the AIA, which was a good complement to the upcoming webinar covering Good Samaritan protection. And then finally, an online form that can be submitted to request help following a disaster. I hope that you take away the following. As engineers, we play a vital role in ensuring life safety after disasters. This is accomplished through timely assessments and expert judgment. These rapid assessments require a different level of skill and preparation than that required while sitting behind a desk or computer. SEER and NCSEA provide critical support in disaster response by tracking, identifying, and deploying trained individuals. With proper preparation, engineers are uniquely qualified to respond to these disasters and help their communities. I do want to leave you with this. If you were not able to attend the NCSEA Engineering Summit in New York last year, I have attached, or I'm showing a QR code for a documentary created by Callum Armstrong based on the stories from the Structural Engineers Association of New York about engineers at ground zero. Super powerful video that I was excited to see, especially right before I was able to visit ground zero for the first time. So if you have seen it and want to see it again, here's your chance. And for those who have not seen it, I'd certainly encourage everybody to take a look at that. And I apologize. I feel like I ran through the slide really fast. Finished a lot sooner than I expected. So lots of times for questions and answers.
Well, Klaus, thank you very much for that presentation. We do have some questions that I'll relate to you so that you can respond. First, there are several questions about logistics. You spoke as a member of a team, but there are questions about communication, particularly when you might expect that there are services that are down, cell coverage and that sort of thing. So, and the live nature of interaction with your presumably other teams and maybe some base camp people. What's it like, and how do you accomplish these tasks in the field?
So typical deployments, once you're identified as someone who's interested and you're sent downrange, we're giving you all the contact information of the incident commander down at the scene, and you check in. And then what happens is every morning you have a briefing, and the entire team gets together. Well, the entire group, all those who have assembled to help with this, and hear the directions for the day, as far as, okay, these are the areas that we're working. You're broken into teams of 3, maybe 4 individuals. You're assigned different areas. You're given all the necessary supplies. You are given all the necessary phone numbers that you may need to contact. Oftentimes you may be given radios, 1 per team, to help communicate. So it's very organized on how you are distributed across the scene. And then regularly there are people who come by and stop by and check on you and make sure that you don't need anything, and make sure you have food and water and all the supplies that you need. So there's a regular contact. And then at the end of the day, there's always a debrief where we make sure that everybody is accounted for. Any final data is uploaded. Typically, we use an app on a handheld device like a tablet or our cell phones to document the conditions, and that information is uploaded periodically through the day through the incident commander, so they have that data real time. But there is a very good system in place to make sure that everybody is coordinated. This is why it's really important that you do not self-deploy. You don't want to think, okay, I have the credentials. There's an incident that happened, in the adjacent county. I'm going to go down and help, because you just can't show up and help. They need to make sure that everybody's there for a reason, that you're accounted for. You know what the protocols are. You have the training, and you have the support, because you don't want to be in the field, downrange, by yourself, trying to do this work, because it can be risky, especially, following any type of disaster. Conditions are can be very dangerous.
Okay. The other questions that are appearing relate to the experience both in the qualifications to do this work and in things like the commitment that one needs to make, being ready to go, work-life balance. You're suddenly taken out of your normal life to go and do this. Duration of the assignment, how long in your experience do you commit time to this? How many days, weeks kind of thing? And I know it depends on
Right.
the nature of the event, but what do you advocate I'm trying to crystallize several comments here. What do you advocate for the qualifications and expectations on the part of the people who participate?
So on the qualifications, I would say at a minimum, participating in the Cal OES SAP course or the ICC When Disaster Strikes course, if available. Again, there are some states out there that have their own programs. I think Missouri, Tennessee, among a few others that have their own unique programs. But having at least those certifications and qualifications to be able to do the work. That way, you know how the program works. You know how to assess these buildings in the way they should be evaluated. As I mentioned before, having some professional licensure, whether that's a PE, SE, architect, geotechnical engineer, et cetera, also is very valuable. We need people who, on the engineering architect side, who understand building systems, understand lateral and gravity systems, and can look at these buildings holistically and determine whether or not they're stable or not, or if they're prone to collapse. On the commitment, that's typically the harder part of it, and that's oftentimes what prevents people from doing this work. When, for example, when we went to Puerto Rico, we had a few people deployed through the SEER committee. I think we reached out to 100 plus people in the database to deploy, and we got 2 final commitments just because of the duration and the commitment. Yes, going to Puerto Rico for 2 weeks is a significant commitment, but I will say not all of these are of that magnitude. I would say expect 3 days as probably a minimum, 3 to 5 days probably as an average, because most of these events are fairly local and can be resolved in a few days. But the harder part is not so much the time commitment, but the uncertainty of it, because these things, sure, we know when a hurricane is coming, but you don't know what the damage is going to be and when that call may come. And we all have day jobs, and it's very hard to drop everything and leave. I encourage everybody, if you're really interested in this, have a serious conversation with your employer and talk about the value of this work and see if they're willing to support you during this. Obviously, you're balancing whatever due dates, deliverables, workload, et cetera, that you have to be able to delegate to someone else and deploy during those times. It can be challenging. And there have been times that I have received a call both through, like the SEER program or through my USAR work, whereas I can't do it just because of my other commitments, my work commitments or my personal commitments. The other thing is making sure your family is okay with it, because you're putting yourself in potentially harm's way in a risky situation, because just because there has been some time after a disaster doesn't mean the environment is necessarily always safe. So not ideal conditions, just making sure your family is supportive of it as well. But yes, the time commitment can be an issue. It's just having those open conversations with your employer and your family and your coworkers.
Kind of on a related question, if I were to get involved in this, am I signing up for a nationwide call list, or is it a state by state? How do I express where I'll go, I suppose is
right.
the question.
Good question. Typically, it's going to be for local work, although there have been calls in the past, like if Florida has an incident, they'll put a call out to anybody who's willing to come, regardless of where you are, just to help. The only thing I must note on that, typically that is on you as the responder to find your own transportation and to make the time and spend the money to get down there. So you have to weigh how much time and money you want to commit to it. But typically they are local events. I think Puerto Rico, again, was probably a unique situation where obviously they don't have any direct neighbors to pull from, so they have to pull from the mainland, and they invoked what's called an EMAC, an emergency commitment, I guess you want to say, between states, and ask other states to support them because of the extent of our damage. But a lot of times these are local events, and you don't have to have significant travel time.
Is there a preference for ICC or Cal OES certification?
They're equally as good. I'm trying to think what the ICC, when disaster strikes, covers. Obviously, it covers, what ATC 20 and 45 on the earthquakes and windstorms. Obviously, because the California-centric nature of the Cal OES, it's more heavily geared towards earthquakes, justifiably so. But overall, I think both of them are equally as valuable.
Okay. Can you tell us a little bit about performing a single inspection? And what I'm talking about is how much time do you take? What tools do you have available to you? What happens if the homeowner or building owner doesn't want you there or let you in or doesn't believe what you're saying? So kind of walk us through. You walk up to a building that you're assigned to take a look at. What happens?
Right. So typically, you're in a group of 2 or 3 others. You have on your phone or tablet a app called Survey 123 that has all the pertinent check boxes and that sort of thing for what type of building you're looking at. To identify the building type, identify the address, and a map, so that we'll go back to the previous picture, so that when you upload it, it registers on the database, or excuse me, the packet incident command. So this is through an app called Survey 123 that uploads information that those at the base of operations are downloading. So typically you walk up on a building, you approach the building, you do what's called a 360, where you walk all the way around to kind of get a full sense of the extent of the damages. Because yes, the front of the building may look bad, but again, maybe the rest of the building is not so bad. And again, does it have a secondary means of egress? And you're trying to play that into how you finally placard the building. In this situation with Puerto Rico, if the homeowner was there and they allowed you inside, you could go inside the building to look for interior damage if you felt it was necessary. Oftentimes you walk up on a building and it looks, maybe pretty bad. I'm trying to find like this, for example. In this situation, we don't need to go inside the building, right? We know right away it's a red placard. You really don't even have to do a 360 around the building. It's pretty clear what it is. And it takes you as long as it takes to fill out the form on the Survey 123 app to document everything. and then you have to fill out the paper placard that's posted on the building. The paper placard is for the homeowner and for those walking by so they can see what the designation is and the issues, because typically you write on that placard what the concerns or the issues are, when it was assessed, the day and the time, and that sort of thing. So by the time you look up on this building and fill out the Survey 123 form and fill out the placard and post a placard, it's usually just a few minutes because there's not much to see. Now, when you get to a building like this, it may take longer just because, let's say, the damage is located or isolated to just these few columns, and the rest of the building is in great shape. So it may take a little bit longer to determine whether this is a red or a yellow, and if it's yellow, what are the restrictions? Staying out of this particular area of the building, allowed to go inside and get your belongings, any fall hazards. So it sometimes takes longer to do those. We estimate it should take about 20 minutes to do to conduct an overall assessment, but the fact is it takes what it takes. Especially when the homeowner is there, you're engaged with them. Fortunately, again, you're in a team of 3 or 4 individuals. Maybe one person is talking to the homeowner, one person is walking around doing the assessment, someone else is filling out the placard form or the Survey 123 app. So you can kind of tag team this to speed up the process.
How do you document if you have a situation where a portion of the building is deemed unsafe, but the rest is either yellow or green? How do you communicate, stay out of this area, but it's okay to go elsewhere?
Well, typically you can only put one color on the building. You can't have red on one side and green on the other. So if you have a situation like one part of the building is pretty badly damaged, again, let's go back to this guy here. Let's say the porch is the only part of the building that's damaged. The rest of the building is in pretty good shape. So, and there's a back door. So this could be very easily a yellow placard building with the restriction of staying off the front porch, maybe putting some type of caution tape around it. So in case that the columns fall off any more or something else falls, so making sure no one's in a fall hazard. But let's say the back of the building is in good shape. So you can say maybe the back portion of the building can be accessed only, but staying off the front porch. Or it can be, okay, you can access the building from the back door, gather your belongings, and evacuate the building. So depending on the extent of the damage and the hazard, you can quarantine certain areas off with caution tape and then describing it on the placard. I say that, but we have no jurisdiction or ways to police that, if you will. We can say, stay out of this area. And I've had that happen. I've roped off a porch area of a residential structure, and the next day people had broken the caution tape and had put chairs underneath the porch, and we're sitting there in the shade. There's nothing I can do about that.
Tell us a little about encountering hazardous materials, not structures. What about hazardous materials that you may see or have reason to believe would exist? And it could be mold, it could be asbestos, who knows what. Is training for those things part of your training or otherwise?
So the training basically covers that there are situations where hazardous materials can be found, whether that's some spilled chemicals, that could be mold or mildew inside of a building that has been sitting for a long period of time. And the training is mostly identifying and recognizing that that's a hazard. We are not trained to mitigate those hazards. We are just trained to say, yes, that's a hazard. And then we call back to incident command, like the individuals you see here in this photograph, and say, okay, I have come across this drum of whatever chemical or some other hazard, and let them know so they can then deploy a hazmat team to come out and resolve that or some other process.
You mentioned a call without getting many responses for people to do assessments. What is your sense generally about the demand capacity ratio of people who have volunteered to do this kind of work? And can people from outside of the country, the U.S., participate as far as you are aware?
I don't know of any reason why people outside the country couldn't participate. Again, if they're willing to take the time to come here and help, I wouldn't be opposed to that. As far as the demand and our capacity, we have hundreds of people on the DRRA roster who have the credentials and have expressed interest in participating. But we don't always get good responses when the time comes. Again, I know it's a very challenging thing to drop what you're doing on little to no notice and be gone for several days. So I recognize the challenge there. I really do. I've been doing this, since 2010, and every single time it's a struggle. So I get it. So that's why we have these events. I'm speaking to the AIA in a few months because our architect brothers and sisters are very much involved in this as well. And the more professionals we have involved in this, the better, so that we can deploy the resources that we need when the call comes in. But it is an issue. It is an issue as far as getting people willing to take the time to go downrange.
If I were to sign up, reach out to DRRA and to sign up, there must be some sort of a vetting process that goes on. And how do I learn where I stand? And over time, does DRRA reach out to me just to keep me in the loop, or is it my job to be proactive with DRRA to make sure that I'm still on the list and those things?
So once you go to the website and create an account and upload your credentials, you can go in anytime you want and update new information, making sure your phone number is correct, your email address is correct, that you are still interested in it, adding new credentials as you gain that training. DRRA itself is a website used for the database and for information. So outside of a deployment opportunity, DRRA itself will not reach out to you other than say, hey, we have an opportunity, we need help. Are you willing and able to do the work? I do encourage everybody, if you're involved at NCSEA, to get involved with your SEER committee, your state SEER committee. That's how you can best, stay on top of what we do within the committee. So each state member organization under NCSEA hopefully has their own SEER committee. If you do not and want to start one, please reach out to me and I can help with that. I am a regional coordinator for the Mid-Atlantic region. I cover several states, but even if you're not in my particular region, I can put you in contact with the regional coordinator for your area, and that individual can help you start or be part of the SEER work. And through that, and the overall SEER committee, we can keep you informed as far as what's going on and new changes and updates.
Klaus, why don't you put up your contact slide
Yep.
while we're finishing up the last few minutes here? And in the meantime, how about the challenge of balancing quickness with conservatism and or not being unreasonably restrictive in how somebody should handle their damaged structure? What do you know, there's got to be some stress on your part about getting it done quickly and accurately without putting undue restrictions on people. How do you handle that?
Right. Like I mentioned before, as far as the time restriction, it really comes down, it takes what it takes. There have been buildings that have been super complicated and a lot going on, and trying to figure out how to placard a building may take a lot longer than some other buildings that are clearly a red or clearly a yellow. It's usually, clearly a red or clearly a green. It's usually yellows that are kind of questionable on whether it's a yellow or a red. So it really takes what it takes, but you're right. You don't want to just be overly conservative and slap a red on every building just because you're worried about liability. And that's something that comes up frequently, is the liability associated with that. But you have to balance that. And I admit it's challenging when you're filling out a red placard and the homeowner is sitting there looking at you and asking you, where do I go? And, yes, you want to downgrade it, I guess, to a yellow or something to keep them from having to evacuate their home. But your job is to make sure these people are safe. And you have to be, lean on your training, trust the guidance of the ATC 20 and ATC 45 manuals that do a really good job in explaining some of the things to look for and how to classify the building. And I will say they're coming out with new versions that are a little bit more robust and some of the examples they give to help you come to that determination. But it's hard, I'll admit, because I've put a placard on the building and the next team came behind me and I heard them saying, I don't know why that person put a yellow on that. That's clearly a green, or that's clearly a red, or whatever. Everybody has a little bit different opinions. That's why the training is so important. Using the field manuals is so important, and making sure that we are fairly consistent in our determination on how we placard these buildings, because we don't want to have one team put a green on a building that another team would call a red. There's always going to be differences. Every time I go through the training exercises, even when I work with ATC on the training exercises, there's always, I don't think I've ever seen, even buildings in my mind is clearly a red, there's always a yellow in the group, right? So there's always that one person, which is fine. We all see the world a little bit different. We all have different experiences, different education, different backgrounds. It's just trying to be as consistent as possible.
Well, Klaus, thank you very much. I think we're out of time at this point. I certainly appreciated your presentation, and I've learned a lot. So I think at this point, I'll turn it back to Catherine so that she can finish up.
Thanks, everybody.
Thank you so much, Don. Thank you, Klaus, for this presentation. We look forward to seeing everybody next month for our next installment with Case, talking about Good Samaritan protection. So for those that were asking that question, we are hopefully going to be answering that in a month. On behalf of Case, NCSEA, and SEI, I'd like to thank you for your participation in today's event. This concludes today's program. Thank you, and have a great day.